So a quick review. Remember, this is the old formula. If you have the probability of A or B, perhaps A union B, that's just the probability of A plus the probability of B when the two events are disjoint. And you can extend it if you have three events that are disjoint. And so probability of A or B or C, provided they can't happen at the same time, is just going to be the sum of the individual probabilities. Just a real quick reminder, or perhaps warning, that when you have mutually exclusive events, they can have no outcomes in common. So a single animal can't be both a dog and a cat, or a horse and a cow, or an elephant and a pig. Rolling a single die, you cannot get a 2 or a 5. There's only one face that can show up at any one time, and so they can't have two numbers occurring at the same time. You cannot flip a coin and get a head and a tail. All right? So, so when you see something like this, make sure that you understand that it's a single roll. So if, for example, they say, what's the probability of getting a 2 and a 5 on a single die roll? Don't treat it like it's two dice. I mean, you can get a 2 and a 5. You can get a 2 or a 5 when you roll 2 dice. But on a single die, it's only going to be one or the other, but not both. Okay? Now, you can get a probability on a single die. Probability of a 2 is 1/6. Probability of a 5 is 1/6. It's an or, so you add them. That's 2 over 6, or 1/3. But they can't happen at the same time. You can't get a 2 and a 5. Kids mess that up. Here is your general addition rule. So for two events, A and B, disjoint or not, they will work with these addition rules. And if you ignore the last term, right, this is one with just symbols, this is one with the words. If you just ignore the minus probability of A and B, probability of A intersect B, then what's left is exactly your formula for disjoint events. So this must have some importance. We'll see in a minute. In fact, we'll see right now. So here's a Venn diagram. Remember yesterday, when events are disjoint, they don't overlap. Here you have events in common. A and B are not mutually exclusive. They can occur together. All right? Now look closely. So this green circle is the event that A occurs. And it can occur two different ways. It can occur by itself. It can occur together with B, A and B, right? Now look at event B. This whole circle is event B. It can occur two different ways. It can occur all by itself, or it can occur with A. So if you're going to do an or and add these together, you'll add this circle to this circle. And when you do that, won't you count A and B twice, right? Because you're counting it once with event A and you're counting it once with event B. The intersection, right? You just want one value, like one A alone, then one instance of A and B and one instance of B, right? So if you're going to add the two together, you get two instances of A and B. That's why you've got to do a correction by subtracting one of those instances, one of the overcounts, to get back to where you're even Steven, okay? So that's how this works. Okay, this is from an old textbook, and Deb is a new employee at a law firm, and the goal of every new person right out of law school is to become a partner. So you can get your name on the shingle along with all the other bigwigs and make a lot of money. She thinks her probability of becoming a partner is 0.7. That's better than 50-50, got a pretty high view of herself. She also came on board when Matt came on board. And so she looks at Matt. She's not too impressed with Matt, not as much. So he's just got, in her mind, a 50-50 chance of joining or becoming a partner. Probability of both, she figures, becoming a partner is going to be 0.3. All right? So if you try to do an or with this, you're going to have a problem. If you do it the way we used to do it with just the addition rule for disjoint events. See, You add this to this, and boom, you're over 1. That's a problem, right? We're going to see why it's a problem, okay? That's not possible. Anytime you get a probability over 1, there's a mistake somewhere, okay? So here is what we're going to do. We're going to look at this Venn diagram interpretation, and we've already got the joint events listed. So here is Deb and Matt. That's where they're both going to be partners. Here's just Deb alone without Matt. So that's D and M complement. Here is Matt alone without Deb, right? So that's Deb complement and M. And this is where neither one becomes a partner. I mean, you got to have all the possible outcomes, and that's one of them. So let me show you how this works. We're going to add up, we're going to find all the joint probabilities. So I'm going to get out of here, and I'm going to pause ever so briefly. All right, that was quick. So here we go. This is a Venn diagram, and we're going to complete it, and then we're going to flip this over. By the way, this is available online for you to print out. It's under reprints. And so we've got Deb and Matt, and so we're just going to go ahead and list the probabilities so we don't forget them. So here's the probability of Deb. Remember, she was pretty high on herself, so it was 0.7. And the probability of Matt, not so much, that was 0.5. And then the probability of Deb and Matt becoming partner, if I remember right, that was 0.3. And that's where you want to start. You want to start in these Venn diagrams where the most overlap occurs. And this is the only spot with overlap. Now you could have one with a third circle, and you're going to want where all 3 overlap. So you work from that all the way to the outside. So we're working from here. All right, just going to use that for reference. And we'll call this the probability of D and M. So we'll go to symbols. And we were given this, right? 0.3. So that'll be 0.3. And let me just change colors here, and we'll put a 0.3 where you can see it. Okay? And let's then go ahead and start defining other things. So this thing that looks like a Pac-Man, the clear part, that's just Deb alone. So that's going to be the probability of D and M complement, because there's no Matt in that clear part, all right? Now, Deb is 0.7. She can be a partner 2 different ways. She can be a partner with Matt or without him, right? So it's one or the other, and or means plus. So this whole circle, the entire thing is 0.7. We know 0.3 of it, so what remains is 0.4. So this part is 0.4, okay? So then we come over here. This is going to be the probability of not Deb complement, and Matt, because it's where Matt can become a partner all alone without Deb. And since he has a 0.5 probability for the whole circle, and we know 0.3 of it here, then that leaves 0.2 left over. So that's 0.2. And so it looks like that might be everything, except if you add it up, that's 0.4 plus 0.3 is 0.7, plus 0.2 is 0.9. Whoops, we are short. This should add up to 1. Well, we're forgetting one joint probability, and that is the probability that neither one of them becomes a partner. So that's D complement and M complement. And that's got to be what's left over, because there are no other options. So there's your 0.1. All right, so start with your overlap, work your way out, distribute the probabilities to, what's left over after the overlap, and then what's ever not adding up to 1 has to be outside of those events. Okay, so let's go back to pausing, because I want to do the other side. So hang on. All right, so this is the other thing. This is a table, and you can work both, either one that you prefer. The table is going to be how I did a lot of the homework problems. You still need to know the Venn diagram. So try to make sure you get a little practice in on it. But again, let's list some of the things that we need. Remember, probability of Deb, she figured 0.7. Probability of Matt was 0.5. And the probability of Deb and Matt, that was equal to 0.3. Okay, so we're going to work on this, and here is where Deb is partner, right? Deb is a partner, goes this way. In fact, all of Deb's events go this way. Matt's goes this way, all right? So we know the probability that Deb becomes a partner, that's going to be 0.7. Now these are all joint probabilities, so the 0.7 goes here, and that's the probability of Deb becoming partner. We should also know the probability that she won't be a partner, because that's going to be the complement. So that's going to be 0.3, and that's going to be the probability of the complement of Deb, okay? And the two should add up to 1. So we can get a grand total. This is like a marginal distribution, so we'll get a grand total. It should add up to 1. So then we can look at Matt. Matt becoming a partner is 0.5. So the probability that Matt is a partner, probability of Matt, is 0.5. Now remember, this has to add up to 1, so the probability that he doesn't become a partner, Matt complement, is also 0.5. Okay? So now we have all the individual probabilities. Now let's go for the joint ones. We know the probability that Deb and Matt both become partners, and that's going to be the intersection of where Deb is a partner and where Matt is a partner. Okay? So that's going to be right here, 0.3. And that's the probability of Deb, D, and M. Well, if you go down here, remember there's two ways she can become partners. She can be either by herself or with Matt. Or means plus, so two numbers add up to 0.7. This is 0.4. And this is the probability of Deb and not Matt. And so then we've done all of Deb, we can go sideways and figure out for Matt. It's the same kind of thing. This plus whatever's in this box equals 0.5. So that must be 0.1. And that's where neither one is a partner. Matt isn't, Deb isn't. So that's the probability of D complement and M complement. And didn't we find that on the other one, on the Venn? So now let's go and add down this way. 0.1 plus something gives you 0.3. That something will be 0.2. And that's going to be the probability of not Deb, so D complement and M. So there we have all the individual probabilities. There are all the joint probabilities. It's really easy. It's simple. I kind of like it. So I'm going to pause here and get back to the PowerPoint to close things out. So stand by. All right, so we did all of this. We figured out all of the probabilities, and so we're good for that. We did the joint probabilities, so let's see what's next. All right, so here's how we just would do it mathematically with the formula. So we're looking for the probability of Deb or Matt. So that's going to be the probability of Deb plus the probability of Matt minus the probability of both. And now we're below 1. So now it should make sense. The probability that neither is promoted is 1 minus the probability that Deb or Matt is promoted. And that's going to be the 0.1 that we came up with. And don't forget, the reason we have to do this correction of subtracting 0.3 is because 0.3 is part of this number, 0.3 is part of this number. It's being counted one time too many, so we just take that one extra one out. And that's it. It's as simple as that. We did the Venn, we did the table. And, all right, so here is your general rule. Probability of A plus the probability of B for the probability of A or B. And since it's general, it's supposed to work for disjoint as well as joint events. Well, the thing is, in a disjoint event, this term equals 0 because there's no overlap. There's no place where you find A and B together. So note, if there is no intersection, if A and B are mutually exclusive, then the probability of A and B right here is equal to 0, which returns us to the addition rule for disjoint events. Guess what? We've been using this formula up here all the time, even yesterday. Everything we had was disjoint, so this wasn't even worth mentioning because it was equal to 0. All right, we did the table in the Venn.